Hey everyone, today we are going to be learning about parallel and perpendicular lines. And I know that you know what parallel and perpendicular lines look like, but today we're going to be talking about determining whether they're parallel, perpendicular, or neither given their equations. And you're going to write equations of parallel and perpendicular lines. So just some review vocabulary for you. Remember, parallel lines are lines that are in the same plane but never intersect. In the same plane, I don't mean an airplane, I mean like the surface of a desk would be a plane, or a wall would be a plane, or your iPad would be a plane. So if I drew two lines that never intersected right here on the iPad, that would be a set of parallel lines. Perpendicular lines, you know, I hope, form that right angle. So, and I am estimating, but like that. They're perpendicular. And it doesn't matter which, and I'm not so good at doing it this way, but it doesn't matter their orientation as long as they form that right angle. Now there's some things that we know, and we've looked at this in the past, but now I'm just going to remind you. Parallel lines, since they're going up at the same rate or down at the same rate, have the exact same slope. So if they have the same slope but different y-intercepts, then they're going to be parallel lines. Perpendicular lines, though, are just the opposite of that. The slopes are not only different, but they're different in a certain way. They're opposite signs and reciprocals. So what that means is, if the slopes are opposite, so let's say we have a slope of a positive 1/2. The opposite sign part you get. So if it's positive, the slope of the perpendicular line is going to be a negative. And it's the reciprocal, or the multiplicative inverse. So if your original slope was 1/2, the line that's perpendicular to that will have a slope of a -2. Okay, so this is a very important piece to our puzzle today. Alright, example 1. Now again, be very careful with your reading. It says write an equation in slope-intercept form, so I'm naming the form that I want you to use of the line that passes through the given ordered pair and is parallel to the graph of the given equation. So to be able to do this, remember to write any linear equation, you need the slope, and to be in slope-intercept form, you need the y-intercept as well. But remember how we converted in the last lesson. It's easier to do from point-slope form, but we still have to figure out that slope. Well, if we want a graph that is parallel lines have the same slope. So I'm going to find my slope, and I know the equation of the new line is also going to have a slope of 2. So this is my original. I'm going to go ahead and graph that. So I start at 1, so I'm pulling out that y-intercept, and I'm going up 2 over 1, up 2 over 1, or down 2, back 1, down 2, back 1, right there. And it's easier for me in Notability to draw those straight lines. So down 2, back 1, down 2, back 1. So let's see, it's going to be, oh, that was terrible. Let me try again. Okay, I paused while I drew a new line. It's still not very good. I know that you all, or some of you, know a way to make better lines than this in Explain Everything, but I forget. So that's my line. So now let's work on the one that is parallel. So remember, parallel lines have the same slope, so we're going to have a slope of 2. So the slope of 2. And we have a point. So the easiest way to write an equation in slope-intercept form is starting with point-slope form. So y minus a -5 y minus a -5 equals my slope of 2 times x minus a negative 1. Oh my goodness. Okay, so I'm going to pause just to tell you that, and so I left to get my hair cut early so I could sit in the parking lot and make videos uninterrupted, and lo and behold, someone is calling me. So I apologize that the phone kept ringing. Okay, now here we go again. So all I'm doing is putting it in point slope form, and then I'm going to convert it, remember, by using that distributive property, and then bringing over what is on the same side as y. So my new equation is y equals 2x minus 3, because 2 minus 5 is a negative 3. So now I can plot that point. So my new point, and remember this one started at 1 and it went, it started at 1 and it went up 2 over 1, up 2 over 1. Now this new one is going to start at a negative 3 and go up 2 over 1, up 2 over 1, down 2, back 1, down 2, back 1. And so I have, if I could draw straight lines, my lines that are parallel. They're going up at the same rate, so they will never ever cross if they were truly straight lines. Alright, so now I would like you to truly, for real, pause the video and try this one on your own. So again, you're writing it in slope-intercept form, and it is going to be parallel to this, and then you're going to graph both. Okay, so parallel to this, so think of what we know about the slope of parallel lines and see if you can write the new equation, and then come back and check. Alright, let's see how we did. First, while I was waiting for you to finish, I tried to find my straight lines, and now I have them straighter, but they're still not great. Alright, so our original slope was negative 1/3, and the y-intercept was negative 3. So I started there, negative 3, went down 1 over 3, down 1 over 3. So you can see my line is a little bit off. And then for parallel lines, we know that the slope is going to be the same. So I just took that slope, I plugged it in here, I plugged the y and the x into my point slope form. I used the distributive property. Since this was 0, it was very little work. And so now I have this 2 is my new y-intercept. And I went down 1 over 3, down 1 over 3, and you can see that these are parallel-ish. But they're really supposed to be parallel. Okay, so it's easy as pie. Parallel, pull out the slope, and you plug it in using point slope form and transfer it to slope-intercept form. Alright, example 3. Instead of parallel lines this time, they're going to be perpendicular to the graph. So we still have to start by pulling out the original slope. The original slope is 4. So my perpendicular slope, the new slope, is going to be the opposite of that, but also the reciprocal. So instead of 4, it's going to be negative 1/4. And then we'll go from there. So we'll plug in, here's my x, here's my y, and again, I want to make sure you're understanding that what we're asking is for a line that is perpendicular to this one, but goes through this point right here. Alright, so I'm going to use this point, y minus a negative 3, which is y plus 3, equals negative 1/4 times, this is going to be icky, isn't it, x minus 3. And then we're going to use the distributive property. Why would I have made such a problem so icky? Equals negative 1/4 x. Negative 1/4 times a negative 3 is a positive 3/4. So when I get to graph it, I'll show you why. So this is plus 3, so we have to subtract 3. So now I have y equals negative 1/4 x 3/4 minus 3 gives me a negative 2 and a 1/4. So then we have to take the time to graph it. So the first one is pretty basic. We're starting at 2. So my original, we're starting at 2. And we're going up 1, 2, 3, 4, and over 1 in the positive direction. Up 4, over 1, down 4, 1, 2, 3, 4, back 1. Alright, that's the best line I could come up with. Alright, for this one though, because of that, this, we have to be a little bit more careful. So now we have to start at a negative 2 and a 1/4. And it's easier if this is blown up a little bit, negative 2 and a 1/4. But now you're going up 1 and back, so I went up 1. Remember, I'm not hitting right on the grid because I was in a fraction, and then over 1, 2, 3, 4. So it would be a line, and again I would do that a few times, connecting those two, and there is your right angle. Alright, time for you to try it on your own. Remember, you are trying to take your original equation and graph it and find that perpendicular line that would go through this point, perpendicular to this. So remember, perpendicular slopes are opposite reciprocals. Yours is going to be much easier than mine. Pause, try it, come back. Alright, maybe yours wasn't any easier. The second equation turned out to be looking like it was going to be easier. So the original equation had a slope of negative 1/3, so we had to take the opposite reciprocal, so my new slope is 3. So I plugged that in, y minus 4, because here's my y, equals the slope times x plus 4. I distributed it out, I added 4, so I came up with this beautiful simple equation. The problem is our scale didn't go all the way up to 16. So I numbered, and I don't know if you can see it in here, I numbered by 2's, excuse me, yawn, so I could get that on there, but then it made the first equation a little tricky. So I numbered by 2's, so here is my original y-intercept, and I went up 1 over 3, up 1 over 3, but it's in smaller increments. Because the axes are numbered the same, I could have just went counting down 1 over 3, and it would have been the same. You can only count boxes, though, if the scales are the same. So that's what it looks like. Did you get it right? If not, go back, erase, try it again. Alright, this one is pretty easy. I'm going to do my explaining out loud, so please listen. So we have to decide if they're parallel, perpendicular, or neither. Well, y equals negative 3 and x equals 4. From earlier in the unit, we learned that a vertical line is the x equals, and the horizontal line is the y equals. And so vertical lines and horizontal lines, of course, make a perpendicular. So these are perpendicular. Here, I'm going to look at my slopes. That's what determines whether they're perpendicular, parallel, or neither. Since the slopes are not the same, and they do not have the opposite reciprocal idea, these would be neither. Alright, so take a look at these and decide, parallel, perpendicular, or neither. Okie doke, I'm going to look at my slopes. So right here, I have a -4, and the opposite reciprocal of that would be 1/4. So this is perpendicular. Here, my slopes are the same, but my y-intercepts are different. So they're parallel. If the y-intercepts were the same, then they'd be the exact same line. And that is it. Start your assignment. Let me know if you have questions. We out.